Hello, my name is Louise Bianco, and I'm going to talk to you today about the Grade 7 Heat Unit. So in our Grade 7 Heat in the Environment unit, we have a learning goal that is, heat is a form of energy that can be transformed and transferred. These processes can be explained using particle theory of matter. And that comes from our curriculum document using the big idea number 1 and overall expectations 2 and 3. But what's really important, what gets our students going, is our overarching challenge, and that's what they're going to actually do during the unit. And that is to design or improve on a design and build a solar oven that will cook food and sterilize water by applying knowledge of heat transfer by convection, conduction, and radiation. If you look on the right here, you have the resources. So the STAO Critical Thinking Resource Cascading Curriculum is the plan of the unit. And then you have resources for assessment and pictures at the end. And then we have sample lessons. The first one is actually at the bottom, and then 2, 3, and 4. The hook for this unit, the beginning of it, is looking at emergency situations and making a list of all the things that somebody would need in case of an emergency. And then the students are asked to judge which ones are the most important, and then we also look at which ones are related to heat, like shelter, heating food, and sometimes sterilizing water. And then that's how we get into the solar oven, which is one of the aspects of survival. If we have a look at our document where we have the cascading challenges, we'll see that we have the same learning goals and overarching challenge that's been described on the first page. The unit is divided into 2 lines of inquiry. The first line is a series of lessons that relate to our learning goal 1A, which is the effects of heat on matter and on particles. And second learning goal is based on the investigation skills, determining a method of measuring an observable outcome. So setting up the experiment. How will we know that we're successful at doing a solar oven that can actually heat food? These series of lessons, every time the student learns something new, they'll go and modify their design. Same thing happens in the second line of inquiry, but there we'll specifically look at heat transfer in terms of convection, conduction, and radiation, how those actually work and how it relates to the particles and what we can observe in our daily lives, and also our learning goals in terms of investigation skills, using problem-solving skills to identify ways to minimize heat loss and increase heat capture. So related to our solar oven, we'll be testing different materials to see which ones are better to increase heat capture and minimize heat loss. Each time the students do those small experiments, they can modify their design. And eventually at the end, we build the solar oven and have our cook-off. So throughout the unit, I use lab books or thought books for students to write their thoughts in. And at the very beginning of the unit, I ask them to draw their very first idea for a solar oven to cook food. And sometimes it comes out looking like this. The magnifying glass is very popular at the very beginning. And as we progress, every time they learn something new, we go back in our book, we draw our new design, and then at the end, you get something a bit more substantial like this, where they have different parts to minimize convection, to get convection contained, and aluminum to reflect more solar power inside their solar oven. The second document has assessment checklists and rubrics that you could use for the various samples. And these you could go through with your students, use for yourself. But what I would like to show you is at the end of the document, I have some pictures of students with their work. So here's one that is built with Mylar, has a turkey bag and a plate inside. You'll see that in a lot of these, nacho chips, s'mores are very popular, but we've had students also cook eggs, bake cake, and I typically bring a cake to cook for my class. This one's an insulated box with saran wrap and a box painted black. Successful little nacho there. A surprising one, which was very successful, is simply a can painted black with saran wrap and capacitor, like a reflector, sorry. a reflector that heats up the can. Testing out the s'mores. The pizza box is also very popular. I personally don't show them any examples at the beginning, but if they are willing to go and do research and improve on a design that already exists, I'm all for that. In the sample lessons, there's a lot of links with extra resources and how you can take, if your students are very interested, you can take them in a tangent and continue. There's a lot of possibilities for enrichment and connecting with outside resources. Feel free to browse through. If ever you have questions, I'm willing to answer them.